So that is soil stress. Okay. Before that, I would like you to know that for soil stress, we have total stress, pore pressure, and also effective stress. Okay, so we have three types of stress, three types of in situ stress. What is the meaning of in situ stress? Is the stress is experienced by the soil before any loading you put on top of you have any loading been put on the soil. So originally the soil stress, we have total stress, pore pressure, and also effective stress. So what does it mean? Yeah. All right. I hope that you already get the books from I don't know, Dr. Bahtia maybe, right? So this is the formula for stress. As have you guys got the book? Dah dapat buku tak? Hari tu I nampak you guys beli buku kan? Anyone? Ada suara tak? Saya tak dengar suara korang lah. Cuba someone say something, jap. Hello?
Belum, doktor.
Okay. Sekejap ya. Saya nak charge laptop je. Okay, so kalau you guys dah dapat the books, yeah, so you can turn to page, you can see that in page 1, we have some short notes for that. So for stress, what is stress actually? Stress is expressed in terms of total stress and effective stress. Okay, so total stress at any point below the ground surface is due to overburden, meaning that so this is your ground surface, right? So any stress that happen here is due to the overburden pressure. What is overburden pressure? For example, like soil, water, or any object on top of your surface. All right. So without this burden, also you already have the original burden, yeah, which comes from the soil itself and the water inside the soil. So as we can see that as deeper as it goes, okay, so the stress will become higher. So let's say this is your surface, okay, so surface, so your punya stress distribution would be like this, okay. As it go deeper, your stress will become higher, okay. So this is the depth of the point of stress. All right, so here you can see that the formula for stress, which is sigma equals unit weight, which is gamma, times Z. Z is the depth of the point of stress that you want to calculate from the surface. All right. So Z is the depth. Unit weight is the unit weight of the gamma is the unit weight of the soil. Okay, unit weight of the soil. As you know, we have unit weight, dry unit weight, bulk unit weight. All right. Okay, so water, we have unit weight for water also. All right. So some books, they will use unit weight of water equals 10. And some books will use 9.81 kilometer per meter cube. Okay, this is the unit for unit weight, cube, yeah. All right, so I would like to standardize for this class. Let's use 9.81. Remember that, huh? For this class, let's use 9.81 for unit weight of water. That's standardized, huh? All right, so this is how you calculate for stress. Remember this formula as long as you learn geotechnics, because this is so simple formula, it would be given in your final exam. Okay, so you kena ingat, yeah. All right. So what is total stress? Total stress generated by the mass in the soil body calculated by sum of the unit weight of all the material. Okay. In our revision class last few weeks, okay, I already highlight that in soil we have three parts, right? So we have air, we have water, and we have solid. Okay, so total mass, of course, air is neglectable, eh? So you only have water and solid. All right. So for water, for total mass, total stress, um, total normal stress is generated by these two, solid and also water in the soil body. All right. So how are you going to calculate that? Okay, let's take a look after this. So the unit weight of soil is in natural condition and water influence is ignored, meaning that when they said water influence is ignored, meaning that you include the water in your calculation. Okay, compared to effective stress only calculate the stress generated by the soil particle only. Okay, faham tak? Kalau total normal stress, it's including water. Stress generated by water and also solid in the soil body. But for effective stress, only calculate the stress generated by the soil particles only. All right. Okay, let's take a look. All right. Everyone, take out your notebooks or whatever. Yeah. So let's calculate. So let's see. Let's say this is your soil body. We have three different layer of soil. Okay. How I know this is the three different layer? Because they have specific unit weight for each layer. Okay. Although this layer 2 and layer 3, let's see, 1, 2, 3. Although layer 2 and 3, the unit weight is the same, but maybe the material is not the same. All right. So let's just take this example. Okay. So the question is asking you to calculate the total stress at each point. Each point. So which we have point A, point B, point C, and point D. So how are you going to calculate this? Right. Okay, let's take a look at point A first. Okay, remember our formula. Sigma is equal unit weight times Z. Z is the depth, okay? So for point A, your unit weight is 17, all right? So 17 times, so from the surface to the point A, your depth is 1 meter. So the answer is 17 kilonewton per meter square. Remember this unit. All right, remember this unit. All right, so the next one at point B. Okay, let's take a look at point B. So your unit weight for the point B is still in the this layer. Yeah? So your unit weight is still the same. So 17 times what is the depth from surface to B is 3 meters. So equals 51. All right, now let's take a look at point C. Bear in mind that this is accumulative stress. Okay, accumulative stress. Okay, so if you want to calculate by layer, so you must add the first layer first. Okay, the first layer in your calculation. So for point C, okay, for point C, you have the depth for this layer is 4 meter. The thickness for that layer is 4 meter. All right. So how you do it? So unit weight of layer 1 is 17 times 3. The thickness for layer 1 is 3 plus unit weight for this one is 18 times 4. All right. The thickness for layer 2 is 4. So that is your total stress for point C. As you can see, this part actually we take from the previous one. So you might as well go write like this: 51 plus 18 times 4. So you also get the 123 kilonewton per meter square. Remember to include the previous layer. All right, because if you do not do like this, let's say you want to do, okay, point C from surface is 7 meter, right? 7 meter, but the unit weight is not the same, all right? Unit weight is not the same. That's why you have to do one by one. Okay, 17 times 3 plus 18 times 4. That is your unit weight for point C. All right, and then point D, you just add the previous one. So for point D, 1, 2, 3 plus, where do I get the 1, 2, 3 is from the previous calculation, plus the unit weight for this one is 18 times, what is the Z? The depth for a 2 point D is 2 meter. You don't take from surface, don't take from surface 3 plus 4 plus 2 for the depth, the Z for D. So just the thickness from for this layer to point D. So then you will get, actually this is wrong because this one is times 4, but the point D is located here. So this one is wrong. Actually, this one is 2. So you will get your answer. Unless the point D is shift to here, then it is times 4. Okay? Boleh faham tak? Boleh, All right. I think that is so straightforward. Now, let's take a look at pore water pressure. As I mentioned just now, this is the formula. All right, times H. H is also Z, is also depth. Okay, H is the height. All right. Okay, now for effective stress and for total stress is denoted by this one. Total, sigma is stress. So T, total stress is equal effective stress. This is the denotation for effective stress. You have the apostrophe there. Plus pore pressure, mu. That is pore pressure. Okay? All right. Just now we calculate total stress actually. Now we calculate the total. Now we calculate the pore pressure. So how to get the pore pressure is using this formula. It's the same like this. It is the same like this. So unit weight of water times height of water. Okay? So how to calculate this? Right. So let's take a look at this. We also have negative pore pressure, but you don't have to worry about this because we are not going to look deeper into this. But you have to know that if the question is saying that the soil is dry, meaning the pore pressure is 0. There is no water inside the soil. All right? Okay. So I think this is very straightforward. Some of the books using 9.81, some of the books using 10, but our class we standardize by using 9.81 because we are using one answer scheme. Okay, so I will do the answer scheme by using 9.81 so that our answer is not very much difference. Yeah. So how to calculate? It's the same, 9.81. Let's say your height of water is 4 meter. 4 meter. So 9.81 times 4 meter. Then how much? Something like that. Okay? All right. Then how are you going to calculate the effective stress? Okay, remember just now is sigma T, total stress, is equal effective stress plus pore pressure. Or if you want to calculate effective stress is equal total stress minus pore pressure. So this one lah, equal this one. All right. So that is what we want to find, the effective pressure. Effective pressure. That is very importance for our design. All right. So how are you going to calculate? So you know how to calculate total stress, right? Total stress is very straightforward. From here. So this is how you calculate if total stress. and then you calculate the pore pressure. And then to get effective stress, you just minus total stress minus pore pressure. Then you get the effective stress. All right, effective stress. All right, so like this lah. Okay, so you can take a look at this. Okay. All right, but for this class, I don't want you to do the calculation like in calculation like this. I want the answer in stress distribution diagram. So what is stress distribution diagram? So it is something like this. Like this. This is stress distribution diagram. Okay. So you can provide me this one. You will get full mark if your answer is correct. Okay. So how to provide this one? Okay. Let's take a look. Let's do some example. Okay. Okay. Right. So you have here, MAT is the groundwater table. Your water table is here. So meaning that the upper layer is dry. Correct? Dry. So there is no water. Meaning your stress, your pore pressure will start from this layer. From this layer. So most likely your stress distribution diagram will be like this. Okay? Now, let's do one step by step. Yeah. Okay. Okay. First, if you want to make a stress distribution diagram, you have to have three column like this. The first one is sigma, the total stress. Second one is pore pressure. The third one is effective stress. Okay, effective stress. Now, let's take a look one by one. You have no overburden pressure, no buildings, no foundation. So your stress will start from zero here, to the next layer, which is here. So you just time what is the unit weight for dry. Dry is 13.1, right? 13.1 times how much is the H is 2 meter. So you get 2.6. 26, sorry, 26. Okay, now moving forward until here. So 26 plus, what is the unit weight for this this layer is already got water, right? So unit weight saturated is 18. Right, 18 times 2.5. 2.5. So how much? Okay, and moving forward again. So whatever result you get here, you add. You try yourself. I just show you the working calculation. And then for this point, the sigma total would be whatever you get here. For example, let me calculate first. Excuse me. 26 plus 18 times 2.5. 71. So you get 71 here. And then the next one is 71 plus 19.8 times 4.5. So you will get 4.5, sorry. 75 plus 19.8 times 4.5. 160.1 kilometer per meter square. That is your total stress. That is your total stress. Now, let's calculate Sekejap, ah. Okay, let's calculate the pore pressure pula, ya. So, okay, let me use another color. Kuning lah. Okay, kuning. Okay, so seems like our groundwater table start from this layer. So our pore water pressure will start from 0 from here to the next layer until here is berapa ni? 9.81 times 2.5. Okay, 2.5 equal wait. Dapat 24.53. And then the next one adalah 24.53 bukan times, plus 9.81 times 4.5 plus 9.81 times 4.5. So sama dengan 68.67 here, 68.67. Now, how are you going to get the effective stress? Okay, kita guna color lain effective stress. Now, kalau effective stress pula, so you already get the total stress, you already get the pore pressure, so you just minus. Okay, kenapa minus? Nampak tak ni? Okay, so to get effective stress, we just minus total stress and pore pressure. So minus je lah. So 0, 0, 0 here. This one no pore pressure. So you start 0 here. All right, okay. To the next layer, 26 minus 0. So you get 26 here. Next, you must minus the same level. So here you get 71 minus 24.53. So you get 71 minus 24.53. So you get 46.47. Okay, and then the next one is 160.1 minus 68.62. So you get 91.48 kilonewton per meter square. Alright, so if the question is asking you the effective stress at point X, so your answer is this 91.48 kilonewton per meter square. Okay, faham ya? Boleh tak? So this is your stress distribution diagram. So you will have 3 triangles, something like that. So let's take a look. Is it correct or not? So the answer will be a bit slightly different from our calculation. We get 91.48. From the example, you get 90.3. Why? Because they are using 10 for water pressure, unit weight in for water pressure. But roughly the calculation is the same. It's just they use a different unit weight. So your answer must be like this. We have 3 column and then you have triangle like this. Okay, so this is your final answer. Okay, this is what we call stress distribution diagram. Now you guys try this one. Example 3. Try example 3. Okay, I already have the answer, but I want you guys to try it yourself. For the soil profile shown here, plot the stress distribution diagram, including total stress, pore pressure, and effective stress at point. Which point? At point, kat bawah ni lah point A, for example. Point A. Okay, so calculate now. Point A. Practice, Okay, so dah buat Okay, so how to do this? Okay, let's take a look. Okay, kita ada, let's make three column. So we have sigma total, total stress, for pressure, and we have effective. Okay, so for total stress, there is no overburden pressure on top of it. So we start with 0. Okay, let's change the color. Let's change the color. Okay, 0 to this layer, we have 18 times 1, correct? So we have 18. And then the next one is, so at the previous one, we have 18 plus 19 times 0 0.5. 0 0.5. So we have 18 times 19, 18 plus 19 times 0 0.5. So we have 27.5. And then the next one is 27.5 plus 22 times 2 plus 22 times 2. So we have 71.5. Okay. Next, for pore pressure. Okay, for pore pressure, if you see the diagram here, our water only start at this level. So we just, from this level, actually just do the layer like this. Okay, so from this level until the last one is 9.81. This is the pore pressure, times 2. So we have 19.86. Now, no, 19.62. Okay, now for effective stress, we just minus. So 0 to 0 minus 0, 0, 0, then we have 0 here. Correct? 0 here. And then the next layer, you have 18. 18 minus 0, we also have 18 here. And the next one is here. We have, how much is this? 27.5 minus 0, you have 27.5 here. And then the last one, you have 71.5 minus 19.62 here. And then you get, how much is this? 71.5 minus 19.62. So we have 51.88. All right. So that is your effective stress for point A. Okay. Effective stress for point A. Right. Okay. This is your stress distribution diagram. 51.88 kPa. Right. So why our answer here is the same? Because as you can see, they are using 9.81 for unit weight of water. Alright, boleh faham Alright, so that is all for our class today. I want you to later I will give you some exercise for you to practice doing this stress distribution diagram. Okay, so I will see you guys next week to do the overburden estimation, the stress increase due to the external loading. So just now we are calculating stress due to the in situ, the internal stress that is caused by the soil itself without the overburden, tanpa without the overburden, meaning without the structure, external loading. External loading is that structure, foundation, something like that. So this one is what we call in situ stress. We want to calculate the in situ stress. And next week, we will go deeper into the calculation, the stress calculation due to the external loading. All right, due to the external loading. But now I will give you the exercise so you can do it home. Calculate, try the exercise and produce the stress distribution diagram. And I will forward the exercise in the WhatsApp group. Okay? Any questions so far? No question? Faham Bagus dah faham let me see where is the tutorial chapter 1. Okay, so you guys ambil dulu this tutorial and then just do for today, just do question 1A, B, 1A, C, ni susah sikit. Tutorial chapter 2, tutorial lateral earth, chapter 1. Tak apa, nanti I check dulu the tutorial and then I will share with you in the group. Okay? So I think if there is no question, that's it for today. All right. So I'll see you guys next week on the stress increase due to the external loading. So if I'm not mistaken, the coordinator for this subject has decided to do the test 1 on week 7. Okay, week 7. But the date is not sure yet. But you can expect that the test 1 will be conducted on week 7 for chapter 1. Chapter 1 only. Okay. So if there's no question, thank you very much, everyone, and see you guys next week. All right.
Doctor,
Yes.
can I have QR for attendance? Masuk lambat tadi.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Okay.